All right, so what we're going to do now is learn how to draw these two-dimensional Lewis structures. Now, two-dimensional, we mean up and down and left and right with a center atom. We are not going to be looking at 3 dimensions, which means coming out at you and going like back into the screen or into the paper. We're only looking at up and down and left and right. Then we're going to use these two-dimensional structures to figure out what the 3D actual molecule looks like. Now, there's some steps that you have to follow. There's 5 main steps here. And initially, these are going to seem a little overwhelming. It's going to seem like there's a lot to do. This is really not that difficult of a topic. Just kind of trust me. Eventually, these steps are going to become automatic. They might seem overwhelming in the beginning, but as you start to do them and practice them, it's going to get easier and easier for you. Now, the first step is always use the formula, and figure out what elements are in the compound and how many valence electrons they each bring and pool together. Remember, these guys are going to share valence electrons, so we need to know how many they're going to share. So you basically look at the formula. Let's start with this first example here, H2O. So we know that there's hydrogen and there's oxygen. We look at the formula and the subscripts tell us how many there are. So there's 2 hydrogens and 1 oxygen. Then you're going to use your periodic table to figure out valence electrons. So here's hydrogen. It has 1 valence electron. Here's oxygen. It has 6 valence electrons. So that's going to become very important. Hydrogen, there's 2 of them. I'm going to put a little number sign here. There's 2 of them, and they each have 1 valence electron. 2 times 1 is 2. So all the hydrogens are going to donate 2 to the pool, to the bank, to the total that they're going to then divvy up and share. Oxygen, we said, is in group 16, so it has 6 valence electrons. 1 times 6 is 6. Add them all up, we get 8. So our total is going to be 8. So the first step is to look at the valence electrons and count the total number of valence electrons for all the atoms in the formula. You have to use a formula, and you have to use a periodic table to figure out the valence. So come up with the total. Then you're going to pick your center atom. This is going to go in the center of the molecule. Now, sometimes it's pretty obvious what's in the middle. Other times you're going to have to decide. This can be a little guide for you. Your first choice, if you have carbon or silicon, should always be one of those 2. If you don't have carbon or silicon, then you're going to look to see if you have nitrogen or phosphorus. If you don't have them, then you're going to look to see if you have oxygen or sulfur. If you have one of those, they're going to go first in your center. You never, ever, ever want to put the halogens. These guys are group 17 or little hydrogen in the center. So in our case, we have hydrogen and oxygen. We said we never put hydrogen in the center. We don't have carbon or silicon. We don't have nitrogen or phosphorus, but we do have oxygen. So oxygen goes in the middle. The other thing you can think about is symmetry. There's only 1 oxygen, and there's 2 of these guys. So it kind of makes sense that the hydrogens go on the sides. So we're going to do the next step, which is shared. Remember, shared is a line, a bond. We're going to connect all the other atoms with a single bond, which represents 2 shared electrons. We're only using single bonds. So I put my oxygen in the center, and now I'm going to connect the other guys with single bonds. And remember, each single bond is 2 electrons being shared, zipping back and forth between those 2 atoms. Step 4 is unshared or lone pairs. It says use the remaining electrons to give all the outer atoms and an octet. Now, it's important to know that hydrogen will never get these unshared or lone pairs of electrons. Hydrogen has an octet with just a bond. Make a mental or physical note. Hydrogen gets a bond. That's it. You never put extra dots around hydrogen. It only needs to fill that first energy level. So at this point, I've counted up my valence. There's 8. I've picked my center atom, oxygen. I've connected all the other atoms with a single bond. Put a single bond here and a single bond here. I've used any remaining electrons to give the outer atoms an octet. Well, hydrogen has an octet with these two. It has its little octet. It just needs the two electrons, the one bond. So now I get to number 5. Number 5 is where I have to make decisions. You're going to have this little decision-making box, I guess, in your notes and in the examples that we're going to do. Eventually, it's going to become automatic, though, and I shouldn't have to give you this box. But please, in the beginning, until you get really good at this, use the information in this box. Go right down the line. Now, basically, what you're going to be looking to see is how many electrons remain. How many are still in the pool? So, let's take a look at what we've done so far. We know we had 8 total. There's 2 over here and 2 over here. 2 plus 2 is 4. We have 4 electrons in our diagram. We started with 8. We used 4. So 8 minus the 4 that we used leaves us with 4. So we've done everything up to this point, and we have 4 electrons remaining. That's what you're always going to put here. It says after the outer atoms had an octet. After you do step 4, give the outer atoms an octet. Figure out how many remain. I can't stress this enough. This is unbelievably important. You have to know how many electrons are remaining at this point. In this case, 4. Now, if you have electrons left, you're going to end up putting them on the center atom. But if you don't, you have to look at your center atom and see, is it all set? If it does have an octet, you're done. But if your center atom doesn't have an octet, then you have to do some rearranging. You have to take some unshared lone pairs and move them around and make different kinds of bonds. So the big decision making, or the decision that you select, I guess, is all dependent upon how many electrons remain. So figure that out first. After the outer guys are set, figure out how many are left. Write that down. Then go through this checklist right in order. Number 1 says, I was done since the center atom had an octet. Well, does our center atom have an octet? Are we done? I don't know. Let's look. So we see this oxygen here. It has 2 electrons and another 2 electrons. So far it has 4, which is not 8. So we're not done. It doesn't have an octet. The next step says, I put the remaining electrons on the center atom. Well, let's do that. There's 4 remaining electrons. Let's put them on the center atom. Put a little mark there. We're going to do this. We're going to put 1, 2, 3, 4. Now we have none left. Then, once you do something, go back to the beginning. Are we done now? Does the center atom have an octet? Well, it's got 1, 2, another 2, another 2, and another 2. So yes, 2 plus 2 plus 2 plus 2 is 8. It has its octet. So now we are done. So by knowing that there were 4 left, recognizing that initially your center atom didn't have an octet, and knowing you have to put those on your center atom, now you're done. So this is what our 2-dimensional picture of water looks like. Now, I understand that this might be difficult for you to draw this all out. Feel free to draw this stuff on paper. And then afterwards, you can take a look at your 2D model to figure out what your 3D model is going to look like. But if you're struggling to draw this stuff on Kami or whatever program you're using here, just draw it on paper. You have to be able to go from start to finish, though, and do this. If you can use if you have a touchpad screen or whatever, or you can type this very neatly, or you can use like drawing tools and maybe use the straight line or the little circle feature. Use something, or like I said, just flat out do it on paper. They're going to get a little bit more complex, so doing it on paper might be the easiest option for you. Don't get stressed out trying to use technology here. If you can, just do it by hand. All right, the next one, CBR4. Let's go to the beginning and let's go through each one of these rules. Now, the first rule is always figure out the valence electrons. So we're going to look at our elements involved and a periodic table, and we're going to figure out how many total electrons these guys are going to share. So we've got carbon and we've got bromine. What I recommend is writing them down and then use your formula to figure out how many there are. There's 1 carbon and there's 4 bromines. Carbon tetrabromide. Now use a periodic table to figure out how many valence electrons they have. So carbon is here. Carbon has 4, not 6. It has 4 valence. And bromine is here. If you look up, it has 7. So carbon's got 4, bromine's got 7. 1 times 4 is 4. 4 times 7 is 28. Add them up, grand total, 32. So these guys are going to have 32 electrons to share and get everybody happy. That's the first step. The next step, choose your center atom. Decide who's going to be in the middle. So the first choice is always going to be carbon or silicon, which is an element that we have in this molecule, carbon. That goes in the center. The next step is to connect all the other atoms with a single bond, with those 2 electrons. So let's connect all our bromines. Here's 1 single bond. Here's another single bond with the bromine. Here's another one. And here's our last one. Remember, we're doing 2 dimensions, so top, bottom, left, right. So there's steps 1, 2, and 3. Step 4 says use the remaining electrons to give all the outer atoms, not the center, the outer guys, an octet. So let's give all these outer guys an octet. Let's start with this bromine. It has 2 electrons. It needs 8 for an octet. So we're going to give it unshared pairs of electrons. Now it's got 2, 4, 6, and the 2 it's sharing, 8. Same thing with this one. 2, 4, 6, and the 2 it's sharing is 8. The next one, 2, 4, 6, 2 it's sharing is 8. 2, 4, 6, 8. It's all set. So all the outer guys now have 8. Next step. This is where you have to make a decision based on how many electrons remain. You have to do some math and see how many electrons of the 32 still remain. So this is where you count them all up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I've used all 32. 32 minus 32 is 0. So after I gave my outer guys an octet, 0 remain. We need to know that. Then go through your checklist. The first thing says, I was done since the center atom had an octet. Well, does it have an octet? Let's look. It's got 2 here, another 2, another 2, another 2. 2, 4, 6, 8. I am done. I have no electrons left, and everybody has an octet. So this is what my two-dimensional structure of carbon tetrabromide looks like. All right, let's do the next one real quick. We got NH3. So we write down N and H. There's 1 nitrogen in the formula. There's 3 hydrogens. Use your handy dandy periodic table to figure out how many nitrogen or how many valence electrons in nitrogen. It's in group 15, so there's 5. Hydrogen's easy, it's 1. So nitrogen has 5. 1 times 5 is 5. Hydrogen's got 1. 3 times 1 is 3. 5 plus 3 is 8. They have 8 total. The next step, pick your center atom. We don't have carbon or silicon, but we do have nitrogen. So let's put nitrogen in the center. Now we're going to do left, right, top, bottom. I don't care as long as you do 3 sides. Connect your outer guys with a single bond. That's step 3. Connect the outer ones with a single bond. Step 4 is use the remaining electrons to give the outer atoms an octet. And remember, hydrogen never, ever gets those lone pairs. Never gets dots. So this hydrogen has its version of an octet. It's got the 2 electrons. This one has its 2. This one has its 2. All the hydrogens are happy. Now I have to make a decision. But my decision has to be based on how many electrons remain. So let's figure it out. I've got 2, 2, and 2. I've used 2, 2, 2. I've used 6. 8 minus 6 equals 2 left. That's what I'm going to put here. After the outer atoms have an octet, 2 electrons remain. I need to know that it's 2, or that it's 0, or in this case, that it's 4. I need to know what that number is, because that's going to help me when I do the next few things. Next step says, I was done since the center atom had an octet. Well, does it? Nitrogen has 2, 2, 2. That's 6, not 8. I'm not done. Then the next step says, I put the remaining electrons on the center atom. Well, are there remaining electrons? Yes, 2. So I put them on my center atom. And then I go back to the beginning of my steps here. The first thing says, I was done since the center atom has an octet. Well, now that is true. I am done. 2, 4, 6, and then these 2 is 8. I have no more electrons left. Everybody's happy. Now let's get into some more complicated ones.